This is section 2.5, and the bottom line is this section is all about where they give you data and you put it on a scatter plot, right? I mean, it could be with regards to anything, any statistical study or whatnot, but when you plot the points on a graph, your points might end up rather tightly together. That would mean that it does have correlation, and in this case positive correlation. Okay, now you could think of positive correlation because it has a positive slope. Now if you look at this next one, it's negative correlation because the dots, it looks like they're grouped, they're fairly tight, and they're going down from left to right, which means that it has a negative slope. So we would say it has negative correlation. And then over here we would say this has no correlation, right? This is all from the book. These dots are everywhere. So it's not like you could say, oh, there's a line that's going that represents these dots this way or this way or this way. It's just all over the place. So there is no correlation. Do we understand correlation? Again, no correlation. Negative correlation. Positive correlation. All right. Let's move on. Whenever you have these dots, you're going to actually draw a line right through those dots that best represents your information. This line that we draw is called a line of fit, or other books call it line of best fit. And it's also known as the prediction equation, all right? So let's say that this line is a line that best fits. What does that really mean, that this red line's a line that best fits? It kind of like represents all of your coordinates, all of your data. It almost should have an equal amount of dots on top of the line as you do on the bottom of the line, okay? So that's a line that best fits. So there's an example in the book just to show you how they work through it. They give you data. It's going by years and the percent. And the table shows the percent of U.S. households with internet access. Back in 1997, only 18% of the population had it. 2041, 2001. As you can see, it's increasing. And this is old data, 2007. Probably right now it's up in the 80 or 90%. Anyhow, they take this data and they plot it on XY plane, where the years is down here as the x-axis, and the y is the percent of people with internet. So they give you this info, they plot the points, so you got points all over the place, and then you have to make a line that best fits. Let me do this. Let me actually draw a line up here. And if I take this line, you want the line, obviously this, they already drew it, so that's the line that best fits. But if you have your line and you're drawing it and there's too many dots underneath it or too many dots above it, that would be incorrect. So you kind of want it to be perfectly in the middle. Now what the book says is for you to actually pick 2 points, like this point and this point, and draw your line right through those 2 points. I guess for me that really isn't the best way to go about it. The best way to go about it is to draw a line that kind of is perfectly in between all the coordinates. So I would say maybe even this would be slightly better, slightly, well, I don't know. Well, anyway, you could use the 2 points to draw your line, but you don't have to. So let's see how this actually works out. The way they did it on the book, they used the points 5 and 41.5, and they used the point 2 and 61.7. So they used this point and this point. And what could you do with 2 points? You could find the slope. That's what they actually did right here. They found the slope using y2 minus y1. And of course it's ugly because of the decimals. They end up with a slope of 2.89. And then they used a point, x1, y1, which was the first point, 5 and 41.5, and they plugged it into point slope form. So they found the slope by picking 2 points, and then they used the first point of those 2 points to write it all in point slope form. And of course it is ugly because of decimals. And then they switched it to slope intercept form, y equals 2.89x plus 27.05. Now, that equation right there is the equation that represents your line that best fits, and it's called the prediction equation, because if you wanted to find out what the internet access will be for, let's say, year 2016, which is this year, you would have to plug in the years into x to find out the output y, and that would give you your y value on that graph. So let's see how this works on our worksheet. Let's throw this aside. So let's first start out by taking the XY table and plotting those points. So we have the coordinate 1, 1. So you're going to go 1 on the X, 1 on the Y? No, not that far up, because notice this is not 1, 2, 3, it's 3, 6, 9. So when you say 1, 1, you're actually going to go 1 and then 1/3 of the way up. So it's going to be a coordinate that's down here. Not even halfway up. It's a little bit further down, actually. Everybody please plot that. And let's go to the coordinate 3, 5. So you're going to go 1, 2, 3. And 5 is a little bit less than 6. So let's put that coordinate right there, a little bit less than 6. And then let's go to the next one, 4, 7. 4 and 7 is going to be a little bit more than 6, but not even halfway. That's ugly. Sorry. I'm sure you guys could do it on your paper better. Moving on to 6 and 11. 6 on the X and a little bit less than 12. Okay, so 6 on the X, a little bit less than 12 will be about right there. Then you have 7 and 12. 7 and 12, right on the 12. That's a perfect coordinate right there. 8 and 15, 8 and 15, another perfect coordinate right there. And then we have 10, and we don't know. So they want us to find out what the output is for the input 10. And that's, we're first going to create a line that best fits. Now, one way of doing it is to simply draw it. And you kind of want to pick or draw the line that kind of equally separates all the dots or equally goes through all the dots. Now what the book wants you to do is to actually pick two coordinates. So, like for example, if I picked these 2 points right here, that would not be a good representation of the line that best fits, would it? No. Or if I pick these 2 right here, that would definitely not be a good representation of the line that best fits. So the book actually wants you to pick 2 points. So, the 1, 1 and the 8, 15. Yeah, I think that's good. Okay, so let's do that. Let's use the 1, 1 and the 8, 15. And I think on the quiz, I'll actually tell you, use this coordinate and this coordinate. Okay, so you draw your line, and then I'm going to tell you to write the equation using 2 points. But again, the line you could visually see, as long as it's representing most of the dots, that's what matters. You don't want it to be too far up, you don't want it to be too far down, but if you do use the 2 points, 1, 1 and 8, 15, it looks like you get a perfect match right there. So of course you'd have to go through and say m equals y2 minus y1 over x2 minus x1, and I always draw the divisions and subtractions first. So what is y2? 15. What is y1? 1. What is x2? 8. What is x1? 1. All right, so 15 take away 1. No, you don't have, like I said, you want to use points that will give you a good line that best fits. And we went over some examples, like if you use this one and this one, you end up with a line like this. That's not a good line that best fits, right? So you keep looking at coordinates to see which 2 pair of points will make it a nice line that's kind of close to all of them. Are we good? Okay, so let's keep going with the slope. It's going to be 14 over 7, correct? Yes? Which is 2. So perfect. M equals 2. And what else? If they actually want us to write an equation that represents this red line right here, we have to write an equation. And what form do you guys think you want to use? Point slope form? Slope intercept? Point slope, right? Now why point slope? Because we have a bunch of points right here and we have a slope. We just found it. So let's use which point? The 1, 1. So let's first write out the point slope form equation. Whoa. Let me first write out the point slope form equation. It's y minus y1 equals m parenthesis x minus x1. Okay, so our equation will be, man, that line keeps moving. Sorry. Okay, so our equation will be y minus what? Y minus 1 equals m, which is what? 2, parenthesis, x minus what? 1. And ladies and gentlemen, we have our equation right there. Now, let's say they ask you to write the equation, your line that best fits, your prediction equation. They want you to write it in slope-intercept form. What would you have to do to that? Slope-intercept form. That's point-slope form. We have to get rid of the parentheses, distributing, right? And let me rewrite this. If I distribute the 2, I'll have a y minus 1 equals 2x minus 2, correct? Okay, and what would be my final step to get in? Add 1 to both sides. You get y equals 2x minus 1. Because if you add 1 to both sides, you end up with a minus 1. And ladies and gentlemen, this is your predictor line, your line that best fits. That represents this one that we just drew right here, that goes through all the dots. Does that make sense? Now, for the final question, how about number 10, or the input 10? Because if we go... Question?
Yeah.
Okay, so for the final question, we need to answer what this output will be for the input 10. Now, with your visual, you could actually see 10, and it looks like it's somewhere about 20, but according to the actual equation, y equals 2x minus 1 that we actually made, let's actually plug in 10. It's going to be y equals 2 times 10 minus 1, and that will give you an output of 19. So this answer right here is actually 19. You get it? I hope you do.